Accurate and reliable time synchronization in telecommunication networks is fundamental for the superior performance of the upcoming and next-generation paradigms like 5G. This level of time synchronization requires an extensive use of cesium and rubidium atomic clocks. Anyway, these technologies are too expensive to be distributed among several network nodes. Atomic clocks are being replaced by less expensive global navigation satellite system receivers that provide a specific synchronization signal named PPS, or pulse per second. This synchronization signal, properly supported node by specific network protocols, is exploited to distribute network timing synchronization across the whole network at a sustainable cost. Unfortunately, on one side, GNSS receivers expose the network to the risk of radio frequency attacks. On the other side, network timing protocols can be threatened by cybersecurity trust, aiming at degrading network performance up to an actual service denial. So, the big question is, can these vulnerabilities be mitigated by the adoption of Galileo authenticated signals, OSNMA, and by trusted computing? The Root project proposes and tests a new GNSS-based network timing solution against radio frequency and cybersecurity threats to demonstrate the effectiveness and the resilience of these new technologies and an improved reliability of timing distribution within telecommunication networks.